Okay, so welcome aboard everyone again. My name is Chris Arski. I'm one of the consultants with the CARC Consortia, and we are here for session 3 today. I'm not coming to you from my usual location. I'm at actually the CARC office right now, and so nothing is in its usual places. So hopefully we're going to make it through this without any glitches and whatever else that's going on. But as I kind of mentioned at the opening, we did talk about December in our last session, but we just glanced over it. We didn't do a ton in depth. So I do want to do a little bit of a review there, but really December, January, February, when we look at our outcomes, March have very similar. All we're doing is we're just moving the students closer and closer and closer to what the target of the learner outcome was. So let's just say, for example, a learner outcome was to go to 100,000, and we might have been scaffolding starting at 100, going to 500, going to 1,000, going to 10,000, whatever. And we're working our way to getting to whatever that goal is or that target is so that we have the better part of a half a year to really solidify their thinking around where we're going. And some of the things that we've been able to do so far, we're even further ahead than that. But that's kind of what the whole plan was from the beginning, is not to just dive into the outcome because they don't have the background. And we need to give them time to get ready and time to think through the different components, especially if it's new to them. Then we have to give them that time to get caught up. So we have a really action-packed full session today. So if by chance it runs over and you need to leave, just leave, don't worry. I'm going to keep going so that the recording is finished. And then I'll post the whole thing so that we have it. But I will try to get us done here in an hour and 15. So hopefully everyone can see our screen. And if not, just let me know if at any time you happen to lose it. So we'll begin with our acknowledgement. We respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant communities. So as I mentioned, we have been working on a number of outcomes, but always scaffolding. So we're still in those, and we just keep revisiting. We keep coming back to it, tooling up the number, having a new target. So I find that sometimes by this time, like when we come back after Christmas, the January, February, March, the biggest challenge isn't going back and reviewing and getting to the points that we need to get to. It's keeping the students engaged because they've been through this a little bit. They don't necessarily know that we're cycling around, but that they need to have something that's still going to engage them. So maybe it's a new way of approaching it. Maybe it's just an add-on activity that we do, still with the same end products in mind and the goals in mind of getting the students through their outcomes. So we're really going to focus on 4N2, N3, N4. We'll do 5N1, or sorry, 4N5.1 is what it should say, and 4N5.2. And the 5.2 is going to be touched on a little bit more when we do it again in March, because we'll really be ready for some of that material then, a little bit more so than we might be now. But then again, I'm going to say that prefaces depending on where you started, and if you're following the year at a glance, if you're doing it in different order, which is fine, then of course you're going to be at different places. We are going to look at money today again. We're going to look at it through the lens of how do I move the students from those whole numbers that we've been working on all this time and using money to do that, and to really solidify place value, to really make sure that they're getting strong at regrouping and that they can see the regrouping, because with money, I have to manipulate the money to make the regrouping happen, to moving them to dollars and cents, which some of you are already at, I know, but not talking about decimals, not talking about tenths and hundredths, but that's our goal. I mean, that's where we want to get to in grade 4. But how do I transition from that whole number to dollars and cents to the decimal piece? And so that's kind of the movement, the slide that we want to do in the next little while. There is no rush. We don't have to rush to say, put that decimal in there. If we can get them to really think in terms of dollars and cents, the cents are going to take care of the decimal. as long as they know how to work that. First, if I work that part of it, then that regrouping and all that piece just kind of falls into place when I actually start talking about the decimal and what's sitting behind the decimal. And I have lots of options, and the easiest of those options would be for me as a teacher to say, the first number behind the decimal place is called the tenths, and the second number behind the decimal place is called the hundredths. Yep, I can tell you that, but that doesn't necessarily mean you're going to understand. So again, we want to leverage their ability to maybe use money in this case to tell us what sits behind that decimal and what sits behind the second number in that decimal place. So mastery of 12 by 12, you're still working on that. And in some cases, we know that they didn't master 10 by 10. So with time, we have the whole year, we're working on mastery of 12 by 12. But 4N4 also talks about multiplication and division. And so we want to make sure that students also have an opportunity to do the multiplication and division strategies, even if I'm not strong in my math facts. So you can't say, oh, they don't know their math facts, so I can't even do that multiplication with them, or I can't do division. How am I supposed to do that if they don't know that? Those are two different processes. The process of multiplication and division is a process in itself. Knowing my math facts is also a process in itself, but one definitely informs the other. There's no question about it. But I shouldn't be held back from knowing how to do multiplication and division. Show me a strategy then that I could do, that I could still get the right answers, still be doing multiplication, still be doing division. And it's mostly division. That's going to be the issue. Without running into trouble and without running into always the wrong answer. So personal strategies are mentioned in your curriculum, as is the standard algorithm. But if the standard algorithm is not working, they have no idea how that comes together, but they see another method that's working well for them, then let's go there. Let's make sure that they have another strategy that they can use. And I will show you a strategy that has worked well for students who don't know their math facts, but are still expected to be able to divide a longhand division question and get the right answer. So we'll work through that as well. So I just wanted to start a little bit with what are some of our skills that are showing up repeatedly since December, January, February, and pretty much February and March are identical in sort of our year at a glance, only our goal might be a little bit different. But we're seeing a lot of the same skills that we saw in science. And I know that some of you are doing the science 4, 5, 6 right now, and some of you are not. But I guess what I'm wanting to point out is that any of these skills, even if you didn't do the science and aren't familiar with what's in science, any of the skills that we teach students, we shouldn't let them walk away thinking that this is the skill that's about math. This is the skill that's about science. This is the only one I use when I go to LA. Any one of these skills could be transformed and changed into any one of our core subjects. And students need to see that and know that. They need to hear it. They need to be witness to that. So for example, when we look down the list that we have here, we had said when we were talking about in science, especially in K-3, that model, determine, describe, represent, those are big words in science, and they're just exactly the same big words in math. So it shouldn't be taught just in isolation of a subject. They represent when they do language arts. They represent in social studies. They represent when they do health. So students should be taught, remember, we're assessing the skills as well, but also recognizing that they don't just live in grade 4 math. But those are the big ones that we really want to spend our time on. We may not have all the time this year to assess individual skills, every one of them that are in your curriculum. So you may want to pick half of them or the big rocks for this year. You're still going to teach them, but you just may not assess them as deeply as you would some of the others, such as the ones that I've named off now. So when we look at some of them, you have them listed there in the red, and you kind of see the concept that lives beside it, that comes along with it. But again, if you were to look down to towards the bottom where you see the word investigate, or you see examine, or you see identify. Some of those words could be interchanged depending on the activity that you've designed for the student. So you still have some flexibility there as a teacher. Investigate means I don't stand up and deliver the information to you. You're going to do some activity, you're going to do some work, and then you're going to find out some commonalities, some patterns, some similarities between different things that you were shown or asked to do. So those are the pieces that we want them to really start to work on, and investigate's a big one. And so it precludes us going in there and just giving them the information. So let's have a really quick look at December, January, February. And as I said, March will be very similar. So I didn't just split the screen every time. So when I look at what I'm looking at, it's 4N2, 4N4. And in February, we start to expand that a little bit more. We put in 5.1, 5.2. We're going to leave N6 to when we get to it at the end of February or March. We'll be ready for it then. If we're kind of doing the things that we are now, kids should be well-versed and proficient in some of the things that we're going to be working on. And we also see that as we look through across this page here, that we see multiplication facts of 12 by 12. That's ongoing. That's not specific to just number. It would be any teachable moment that we have and any time that we have available that's dedicated to that. We want students to have that opportunity to be working in their math facts. Also looking at some of the pieces that come along with algebra, students represent and apply equally in multiple ways, that there are infinitely many expressions that represent the same number. So we could just even start with that. How many different ways can you show me 124 cents or $124? If I just pick something like that. There's not just one way. There's some efficient ways, ones in which I wouldn't have a ton of bills in my hand or change in my hand. But there's definitely more than one way for me to get to that answer. And that's really where we want them to go, because we're going to eventually move them to the order of operations, and that I have certain orders that need to be done in certain patterns in order to get the correct answer. So they start them off in very basic forms. And then as they move through, by the time we get to grade 6, we are doing our exponents with the brackets, and the whole works are sitting there. So it's important that students have a really good foundation in grade 4 of just the basic starting points of the order of operations. If I go to the purple section, that's our measurement section. It's ongoing. It's just starting basically when you come back after Christmas. And it's talking about angles. And we're going to be unpacking unit fractions today. That was a big rock in grade 3. And they may or may not have had a lot of time on that last year. So we are going to take a deliberate venture back there to make sure that they're very clear on what a unit fraction is. And from there, what we're going to do is we're going to tie in the bits and pieces. So for example, in measurement, you're talking about angles. And it says angles are quantified by measures and based on the division of a circle. They're talking about 1 degree being 1/360th of a circle. 1/360th is a unit fraction. So as I'm unpacking all my info about unit fractions and working with them, then I can just slide into a circle and say, let's look at how this circle is divided into little black lines that go all around. In fact, there's 360 of them. So one of those circles, or one of those lines would be 1/360th of the distance all the way around, which is really the definition of what an angle is. An angle is 1/360th of a circle. So we're going to we'll do a visual of that as well. The actual angle measurements we can get into, we can use our protractor, but that really wasn't where I wanted to tie it in right now. I really wanted to tie it in to the unit fractions and work from there. So as I said, we don't have a lot of, well, there's enough, certainly slides in the main deck, but you're going to see a lot of additional hyperlinks as we go through. So each one of those will be available to you to use in the background as well. So let's have a look first at 4N2, because you've been doing that one for a long time. And it's really just looking at addition and subtraction. In this case, it's talking about decimal numbers. And we said, let's forego decimals and just work on whole numbers. Can they do it one digit and one digit. Hopefully by grade 4, that's not a big deal. 2-digit by 1 digit, 2-digit by 2-digit. Our goal is definitely to get much larger than that because we're looking at adding and subtracting within 10,000. So we're starting to tool up those numbers by now, and we're starting to work into the thousands. But remember that one of the foundations to this would be mastery of 100. If I can add and subtract any numbers you give me that are within that 100 range, if I can master that, I consistently get those right. That's the leaping board for us to go into the 4-digit numbers and into a 5-digit number, right? We don't want them to go beyond until we know for sure they can regroup any 2-digit plus 2-digit number, any 3-digit plus 2-digit number, etc. They need to be really strong in that. Otherwise, all you're going to do is kind of pull your hair out and say, they're not getting this because they didn't get it at the beginning, so they're not going to get it at the end either. So being patient again, we can't stall there forever, but we really want them to have that rock foundation. And that's what we started the second session on, saying that mastery to 100 was a big piece. So we're looking at subtracting, adding. We're looking at, in this case, again, maybe unpacking it with money and looking at it through the lens of having dollars and cents, not dollars, decimal cents, dollars and cents, the words dollars, the words cents. And that I can show you as a student, any dollar amount that you call out to me. I can add any dollar amount that you ask me to add. I know how to regroup because that's kind of our world that we're coming from and still working in. And once I've got that down pat, and I'm really good at that, cents is no different. Cents are just parts of the loonie that I'm building, but how I add them is still going to be the same as what I was doing over on the other side. And once we kind of get that dollars and cents conversation really solidified in students, we can go ahead and ask them, how does this really appear in the real world? So we'll get to that point. So adding and subtracting dollars and cents precedes sort of the tenths and hundreds. As I said at the opening, I can tell you anything. I can stand up and deliver anything as far as telling you place values, tell you what a number is, what it's called, but that doesn't guarantee that you're following along with me and understanding all the components that I want you to understand. So this first slide deck will be just working with dollars and cents. I will go a little bit fast because I just want to get through all of our slide decks so that you see them, and then it'll give you a chance to go back and have a look at them. So in this particular case, you have a template that I'm going to put into the folder for you to grab. And that template looks like this. It actually comes on an 11 by 17 sheet, and there's, I think, 6 of them on there. So I just cut them into strips and give them to one to each student. And really, all I want them to know is dollars and cents. Notice there's no decimal on there, and I just grade them differently. Just familiarity. That's all I want to know. And I'm going to ask them questions like, do we know how many dimes go into a dollar? And by now we should know that. So 10 dimes would be a dollar. So if I have 10 dimes, I could trade it for a loonie. Correct. Okay. Yeah. How many pennies do I get to put into a dime before I can trade? 10. All right. How many pennies do I need to get to trade in for a loonie? 100. Okay. That's it. We don't need to go bigger than that. We don't need to start throwing things at them because we're just going to work with quick call outs. So the first thing I normally would do, and if this is new to you and you haven't done the money yet, or you don't have the money, you can always do it digitally because we have that one app that we shared with you, that you could just use those values. I would ask them to show me each one of these values. I just want to make sure that every student knows exactly what's supposed to go underneath each of those headers. So the $1,000 bill, remember we had photocopied, they're on sheets and templates because they're no longer made, but for our purposes in math, getting up to 10,000, having the $1,000 bill is kind of helpful. So I put it in there and students are thrilled to see what it used to look like. They know that it's not in circulation. Hundreds, tens, the loonie, here's my dime, here's my penny. But what you also have here is a base 10 system. So I have 2 separate containers for money. I have plastic bags, which have every coin, every bill in it. So when students are learning it, just show me $1.24 or 124 cents, any way you want. They can go in their bag, make whatever combination they want for 124 cents. And I'll say, leave it alone. Just leave it on the table. Good job. Now show it to me again. Because one of your outcomes is any number can be written in multiple different ways. And that's a good example and a good way for them to realize that I can count coins all different ways to get 124 cents. Not always the same coins. So the same thing's true here. I want them to be just familiar and know what is in here. This decimal that would normally exist, we'll put that in at a later time. It doesn't have to be now. So once they've shown me all the values, I'm going to ask them to just have their money in piles in front of them. I usually have them put it above this template so that this area below the template is their workspace. So now I can say, show me $23. And I'm going to ask them to show that to me with the base 10 money that they have from their the second bag there, or their Ziploc, which is only going to be $10 bills and loonies. So they could try and count out 23 $1 coins. And the first time I did this with a large group when we had teachers in the gym, there were some that came up, she said, you know, the kids are just counting out 23 loonies. I said, they can count 23 loonies, but they're not going to find 23 loonies because I don't have that many in each of those containers. So at some point they're going to say, I don't have enough. At which time we're going to simply say, then how else could you do this? I'm not going to say what they have to pull. I'm going to say, what else do you have available that would allow you to make $23? So it's, again, not providing the solution to them. It's giving them prompts. But yeah, it would have been a good count if you had enough, but you don't. So 2 10s, 3 loonies. And then below that, I'm going to ask them to show me $16. So below that, they're going to show me 16. Now, we did this earlier today with a group of teachers. So as we were doing this, I'm calling this out and doing it at the same pace that I would with students. And this is really when they have it laid out in front of them, that's about the pace I would say, show me $23. And they're quickly grabbing. And I said, right below that, show me 16. This isn't a whole minute of waiting time. They will get the hang of it pretty quickly. And they do like working with the money. So once I show the 2 values, then I can say to the students, how much money do we have in total? So how much altogether? And really, when we talk about place value and we tell students we have to line the 10s up, line up the 1s. Again, if I'm not a math wizard, I'm not necessarily understanding what that means. All I know is I have these digits. It may not mean anything to me yet to have 10s and 1s. But here, I have the 10s and 1s. The 10s are purple. They are $10 bills. There's no mistaking that. And the 1s positions are very clear. They're the loonies. So when I add these up, I pull my 10s together. I pull my 1s together. I can't create something new by coming up with a paper coin. And I say that because if you have a 3-digit number and you get those students who want to add the 2 digits and move them all the way over to the left, they wouldn't make that mistake if they already had done this, because then they know a $10 bill, that's what I have, it was $34, can't be added to 100 to create something new. It just doesn't come up that way. So like bills, like coins are going to go together. So I can add them up, get my total. Once they get their total, they can check it with a partner. You can have thumbs up, run around, have a look, whatever, however it works best for you. And then I quickly say, put your coins back, put your bills back. So they quickly put everything back in their piles and we do it again. So this time I'm going to ask them to show me $28. So they're going to by now know that it's efficiency to use my 10s and my 1s. They don't have 5s because this is on a base 10 system. And the reason I'm doing that is to replace the base 10 blocks, not permanently, just right now to make it real. This is real. This is the real world. The base 10 block is not the real world, but I still want to use the base 10 blocks to add later. And if a student gets stuck with the abstractness of the base 10 blocks, they will convert it, the title of what they see, to money. You'll hear it. It just comes out that way. So below that, they're going to show me another $16. And so the first time we do this with students, we would ask them, how much money do we have all together? and they will add all of my coins together. So I have 8 there, 6 there, there's 14 plus 10, 20, 30. So 30 plus 14, I have $44. And if it's the very first couple of times I'm doing it with students, I'd say, thumbs up, 44 is the correct answer. But I don't like walking around with 14 loonies in my pocket. Is there anything that you could do to make that a lighter load? So what we're getting at is the regrouping. Oh, I could take 10 of my loonies and trade them, put another $10 bill in here, and have only 4 loonies left over. Great, awesome. And some students did it automatically, and some they counted, they got 44, they saw what they had, they counted them all up, and that is fine. But from here on in, we're going to say, but now on, I'm not going to tell you or ask you, do you have too many coins? I want you to always check to see whether you can do some regrouping. Can you do some trading? One of the things I want to point out to you as students, it's not intuitive for them to know what direction do I do the trading in. So we need to teach them that when we're doing an addition like this, even if there's hundreds and thousands here, we start from the right and work our way to the left. So I'm going to see if there's any loonies that I can convert into a $10 bill, trade and convert. And then if I have too many 10s, can I trade and convert them for 100 and so on? Some students will start otherwise anywhere. They'll just go, oh, I have so many 10s, I'm going to trade it. But if it's a subtract question, that might be problematic for them because they may have to come back and grab that bill back out of there again. So it's important for them to understand that they're working from right to left when they are looking at what the totals are. When they're adding, they are working from right to left. If I looked at something like this question, say, again, quickly, I'm going to say, show me $134. Below that, show me $217. How much money do we have? So we're purposely grabbing them this time, one where the regrouping of the coins is going to happen. And so I'm going to only end up with 1 loonie left over, but I'm going to regroup and I'm going to get another 10. Once you start getting to the algorithm, like if you're using the traditional algorithm, that's our goal down the end. It's important that when we have the money, let them have the money beside it and they can be writing down the process on paper and pencil if that's what your preference is. But it's also important that we model correct language, not just the doing, but also the naming of what we're doing. So 4 and 7 gives me 11 loonies. So I'm going to leave one of the loonies in the ones place. I'm going to carry the 10 into the second column, which is the 10s. We need to name the one that we're carrying as a 10, or name it as 100, or name it as 1,000. Instead of just saying carry a 1, carry a 2, carry a 3. Because again, that leads to misunderstandings about what am I moving, what am I not moving, and where am I moving it to. So it keeps it sequential for them. Okay, I could do another one, 219 and 177. And again, you're going to see there's regrouping here. There's not going to be regrouping in the second column. So it's a repeat of kind of what they did at the beginning. And eventually I'm going to give them questions where there's multiple regrouping. So if they're ready, I'm going to go 9 and 7. There's regrouping. I'm going to go 1 and 9 plus the 10th that's going to come over here. So that's going to give me regrouping. So we're going to go through this at a pace that they're ready to handle. I'm just fast forwarding right now, but I would be doing a whole day of tons of addition with regrouping, with no regrouping, mixing them up, doing those kinds of things. And I would have some with thousands of dollars as well. Show me 1,127. Below that, show me 287. And again, there's some regrouping that's going to take place there. So they need to know that all things could be regrouped, not just coins get regrouped. The mastery of addition and subtraction within 100 is kind of imperative. If they can nail that in regrouping, they've got it. Then we can move on to the hundreds. We can move on to the 200s, 300s, 400s. They have to master that piece first, though, because if they can't even regroup, let's say 79 plus 27, I'm going to have trouble when you put a 1 or a 3 or a 4 in front of that, because it's just an added digit now that I have to deal with again. So that's kind of an important piece. We also want them to be able to estimate what should their answer be close to. And again, you might have to rationalize with them how they determined their number. So for example, the first one, 134 plus 217, a student might say it's going to be over 300. Yep, you're right. It is going to be over 300. They just rounded to the first 100 that they saw there. They ignored everything else. I might push them and say, do you think it's going to be close to like 350, like halfway between 300 and 400? Not that that's significant, but they could go 130, 220. That would be fine. But just want to understand that they know what they're talking about when their answer is an estimate. Because is it a reasonable estimate, right? We want to make sure that they can do that. And that's from your curriculum as well. You want to be able to do that with them. So again, I could do the same now with subtraction. Show me 134. And once you've shown that to me, I want you to take away 32. We all know that students would much prefer to do adding over subtracting. So would most adults. Because subtracting means I have to regroup in reverse. And that is a little bit more difficult for a lot of students to see or to understand that I don't have enough in the number that's at the top. So I have to do some regrouping in order to get enough to pull away or to take away the value that I'm trying to. The flip side to that, of course, is that multiplying and dividing. Students would much sooner multiply, so would adults, over dividing, especially if it's long division. Most of us would grab a calculator, would grab our phones, and not do the long division. We would just put it into our phone. Show me 278, and from there, take away 59. So I might say to students, help me out here. Do I have to regroup or not? And some of them will say yes, and some of them will say no. And the ones who say no, I'm going to grab them first. Tell me why I don't have to. Well, because 9 can take away 8, right? And that's a common mistake. They'll take the largest number minus the smallest. So we say, but this number is my total, and I want to take away from this number this amount. Oh, well, then I'm going to have to borrow. I'm going to have to borrow some loonies because I only have 8 loonies. I need to take away 9. Where am I going to get more loonies? I'm going to borrow a $10 bill and convert it back into loonies to make it 18. So they can physically see the conversion. And that's really, really key. But you might also say to a student, is there another way? Is there some other ways that some of you might do this, especially your students who'd like to do things in their head? You might have students that say, well, I'm going to take away 60 because 60 is easy. And then I'll just add 1 back because I took away 1 more than I had to. Great. That's great thinking. Some students will take away 50 and then they'll take away the 9. They still have to regroup, but it just gives them solace that they're doing it in different chunks. 412 and take away from that 123. So when we look at the problem, I have 4 hundreds, 110, 2 ones, and I can see them. I need to take away 100, 2 tens, don't have that, 3 ones, don't have that either. So I'm having to borrow all the way over into my hundreds. So again, they can see it. They can actually count them out, see what they got, and then if I need to borrow a 10, which I do here, to convert it into an additional 10 loonies. The money offers us exactly what we would do on paper and pencil. It's just visible. And that is the world for a lot of our students. To see it is to believe it, like to get it, to really understand what it is you're asking me to do. And I can do the same thing with thousands. Now, I wouldn't necessarily show you or say to the students or show the students what I'm showing you right now. In actual fact, when I'm doing these kinds of questions with students, I call the numbers out. I might have them jotted down for myself, but I just call them out because one of the things is that students also need to be able to write a number from the written word. So when I say, show me $134, instead of showing you 134, I'm just saying, show me $134. Okay, put together what you need to put together. So that's good practice for them. When you get into the thousands, it becomes a little bit more problematic because it is helpful for them to see the numbers and yourself, for you to remember what number did I actually just give them. The thousands, you need to start maybe jotting it down somewhere. So what happens now when we introduce what we haven't used here? Let's put the cents in here. I could ask exactly the same kinds of questions, only I'm not going to put a decimal in. I'm going to say it. I'm going to say, show me $134.65. Remember, the word "and" was the decimal. We'll get to that in a minute. So show me $134.65. The same thing will happen with the pennies. They will go for 65 pennies first. If they've never done it before and they're not thinking in terms of money, they're going to run into the same problem. There won't be 65 pennies. So they're going to have to rethink, how else can I do 65? So I could use dimes because that's the only one that they have besides the loonies. And then I can balance off the rest with the pennies. So they can show me this amount. And then below that, they're going to show me $211.27. And again, I might even just say, oh, and by the way, you know, how many pennies again did we need for a dime? 10, oh, 10, right. Okay, good. Just now I was just checking for myself, right? Just that prompt, because I've got more than 10. So I have to think, okay, got to regroup, go back, get another dime. Another question, I could go $1,234.27. And below that, you're going to add $1,006. That's a good one to call out, and 34 cents. $1,006.34. And when they have the zeros in them, you know how students will struggle. They have to think about, what is it you just said to me? What parts are there? What parts are not there? So you could proceed this way, doing lots of questions, dollars and cents, dollars and cents, dollars and cents. And they will go through these and do them just as quickly as they can, and they'll still get the right answer. They can check with their partners, partners can check their work, etc. Okay, and I can keep doing that. I can do that same with the difference. Dollars and cents, take away what I have. At some point, though, I'm going to ask them, so when we go to the store, do I see $17.65? Is that what you see on the sign? And this will be a good formative for you to find out who really knows anything about money in the terms of dollars and cents with a decimal. And a lot of them will tell you, no, they don't have the word "and" in there. Well, what do they have? Well, they have like this point. And I've heard that from many students, this point. They have a point. What kind of point? Well, it's like a black ball. What is that black ball called? Anybody know? And a handful of students may say decimal. It's not necessarily something that they know intuitively. And so we go, oh, so 17.65 would be $17.65, right? So that you could practice writing dollars and cents with decimals instead. You're calling "and," but they're writing a decimal. And we can tell them that the word "and" is actually replaced by that point, which is called a decimal. And that's the only thing that that point does, is to separate the cent sides, the parts that haven't yet been able to get to becoming a loonie, and all those that are dollars on the other side. So one side is building to become a loonie, and the other side is already loonies and converted into larger bills if need be. Okay, so we're going to leave that one for now. Go back to our main slide deck. So using that would really help in getting students to think about where they need to be and what they're going to be doing. 4 and 4 is multiplication and division. Again, as I was mentioning before, I shouldn't be held back from learning the process of multiplying, even though I don't know my math facts yet. It's going to be difficult for sure, but I might give them the math fact tables where they still have to be able to maneuver through the tables and figure them out in order to figure out what product parts they're doing. That would be realistic. We can also look at your second skill and procedure. It says investigate patterns in multiplication and division of natural numbers by 10, 100, and 1,000. And they didn't just sort of throw that in there just by happen chance. That's a pattern. That's an easy pattern for students. Multiplying by ones and tens and hundreds and thousands is easy because once they get the pattern and know how it works, It's not very difficult for them to get a right answer. But it's those very three things that also will save me as a student in long division if I don't know my math facts. So we could say, could you look for patterns? Let's see what happens when we multiply things by 10, by hundreds. We'll just start with that for now because we'll stick with money. And so again, I have an example set down here that we can use. I'll slow in loading here. Oh. For some reason, we're at the bottom of it. Let me just go up to the top. So when I look at patterns, I could put some money out and let them come up with some patterns first. When I have one $10 bill, 1 times 10, I got 10. When I have two $10 bills, 2 times 10 is this number with the 0, 20. 3 $10 bills, 30. 4 $10 bills, 40. The 10s are easy. Those are the ones they learn the easiest when they're doing their math facts, for sure. And we can ask them, what's the pattern you're seeing? Oh, it's just the whole number, the number that's in front, natural number. And when you multiply it by 10, you add a 0 to it. And that's the answer that you get. That's good. That's a good pattern to see. So then you can predict what 8 times 10 would be. Yeah, it'll be 80. Okay. Well, what about 9 times 10? 90. What about 10 times 10? And that might stump some of them because that's moving into a 3-digit number, which would be 100. For most of them, they'll manage that. I might say, how could you prove to me that 10 tens is 100? How do you know that? Because it just is. Well, no, I want something a little more tangible than that. So what do you have available to you that can prove to me that 10 tens is 100? I could take 10 $10 bills and skip count them out and add them up as I go and prove to you that, yes, it equals to 100. So that's one way that they could check. So now let's use that same patterning for 100. I have 1 100, 2 100s, 5 100s. So the pattern is very similar. The natural number times this, I add this many zeros behind. So I'm seeing a pattern unfold by multiplying by 100. So can we predict what the pattern would do if it was by 1,000? And in this case, they'll go, yeah, that'll be 1,000, it'll be 5,000. You add 3 zeros instead of having just 2 zeros or 1 0. So the general rule is whatever is being multiplied either by 10, 100, or 1,000, depending on the number of zeros in the question, that I'm going to be able to add those in for my answer. So I could do some really quick ones. These aren't meant to be done on paper. They could be done orally. You could point out students, you just double checking to make sure that they've got it and that they understand what's being presented here. So then we have a question that says, multiply and divide 3-digit natural numbers by a 1-digit natural number using a personal strategy. Well, do they have a personal strategy? What kind of strategies do you teach your students to multiply? And that's a question to ask yourself. Like, what do we do in our class outside of the standard algorithm? What do we use to multiply? Where do we go? And I've got a little note here that says multiply and divide 3-digit natural numbers by a 1-digit natural number using a standard algorithm. The standard algorithm has inherently got something to be carried. And it goes back to what I said before. We need to model that and ensure that we are using the right language when we carry or we are regrouping something. They need to hear us say, I'm going to carry 2 10s. I'm going to carry 1 100, so that they understand what that 2 and that 1 that we're writing at the top of the column means and why it's there. So multiplying and dividing a 3-digit natural number by a 1-digit natural number is, again, maybe I'm going to use an expanded version. Maybe I'm going to use regrouping. Maybe I'm going to use just breaking the numbers up into smaller chunks. Before I do that, I just want to play this short little, oh, no, we can't play that short little video. I'm going to encourage you to play that short little video. And I'm going to ask you whether or not you're hearing and seeing the modeling that we were just talking about. Lots of great examples in there, lots of work that's being done on the side to model for the students where they're getting it. But listen carefully when they're writing the numbers down. And again, are we supporting our students in understanding the pieces that they need to do when it comes to regrouping? So personal strategy could be, I'm not saying it is, could be, I take the number 253 times 7, I break it up into 200 plus 50 plus 3. And each one of those gets multiplied by 7. Or maybe that's even too big for me. I don't like that. So I'm going to take 200 and break it into 2 times 100. 50 into 5 times 10 and just leave the 3. Oh, got an extra bracket in there. Okay, times 7. So that means that this is going to get multiplied by 7, this gets multiplied by 7, and this gets multiplied by 7. Well, 7 times 2, I might know that already. I could look that up on my table, is 14. And I already know what's going to happen when I multiply by 100. Here I have 5 times 7. I could skip count them on my fingers, 5, and get to 35, and it was times 10. And 3 times 7, I could either use my table or know the fact or do repeated addition and get 21. So now that I know the rules and the patterns for zeros, I will have 1400 or 1400, 350, 21. And really there's no regrouping or carrying right now. I just simply add those numbers up. Again, for some of your students, this will resonate with them totally. That makes total sense to them. But a lot of our students who really struggle in math sometimes do better with a box method. And the box method does almost the same thing that we just did, but even gives them the opportunity to break it down even more if they wanted to. So I could just break up 253 to 250 and 3, and then I'm multiplying by 7. So 200 times 7, I could fill it in if I know that. And our average students will do this, no problem. Or maybe I don't like it. I'm going to go back to the 2 times 100. 2 times 7 is 14 times 100, and then I can write 1,400 below that. 5 times 7 is 35, times 10 is 350, and so on. But even then, some of our students will struggle with having this. This is even too complicated to have 2 times 100. So they may break it up into 100 and 100. There's my 200. I had 5 tens, 1, 2, 3, 4, 5, and I had 3. And some of the students that I work with right now will take the 3 and make it a 1, a 1, and a 1. Fine. If that makes sense to you, work on it. So this is my strategy, my personal strategy of how I'm going to multiply numbers. And it might look like, oh my gosh, look at all the boxes. But for the child who this makes sense to, the number of boxes is insignificant to them. So in this case, 7 times 1 times 7, or 100 times 7 is 700. 100 times 7 is 700. I just fill these in. And then I still have to add them all together. So still going to be a little bit of regrouping here when I get to these 70s for sure. Or I can do it this way. I'm going to break my 7 up into ones. I could break up the 3 into ones. 100 times 1, 100. 100 times 1 is 100. 100 times 1 is 100, and so on. And then they just simply count them up. Count up all the hundreds, just count them as they go. Add in the tens, count them as they go, and then add in the value of the 3 plus 3 plus 3 plus 3. This was where a lot of our students who struggle in math find a home. This box method, although it looks huge, makes sense to them. And they can handle the simple mental addition that they're going through. And even if they didn't, they could add up all the hundreds and write them over here. Add up all the tens, write them over here. So it's another strategy. I'm not saying that this is the only strategies. It's not the only ones that students would necessarily gravitate towards. But the box method is very popular with all kids. It makes sense to them. It's an easy one. So now I'm going to take my rules that I just had of multiplying by ones, tens, hundreds, thousands, and leverage that to do a long division. I don't know my math facts. I read this question, 868 divided by 7. I don't know. I don't know how to do that. And so we say, okay, but What do we know how to do? We're dividing by 7. We know 1 times 7 is what? 7. Okay, what's 10 times 7? 70. What's 100 times 7? 700. What's 1,000 times 7? 7,000. Ooh, is that bigger than this number here? Yeah, okay, let's cross it out. We don't have to worry about that one. And now we're simply going to grab from our legend over here what I can do. So I know that when I did the 100, I got 700. 700 is smaller than 768, so I can put that in there. I can subtract. No regrouping. That doesn't mean there won't be, but right now there isn't. I'm just going to go in groups of 10s now. A 10, 70. 70 is definitely smaller than 168. So I could put it in here and subtract. I could still have room for another 70. So all I'm doing is beside each time I put a number down, I'm putting down what value it was that I multiplied by. And I might know that 7 times 4 is 28. I might not, and I might just subtract 7, subtract 7, subtract 7, subtract 7, do it once. 1, 1, 1, 1. In any case, all I need to do is add up this side, 124 is my answer, no remainder. So this little system here wasn't just for the benefit of decimal moving that we're going to do, but it's also about surviving a longhand division that can be done by any student just using this method. Any sized number. It doesn't matter. If this number had been 177 and this was 86,000 whatever, it'd be 177 up here times 1, 177 times 10, 177 times 100, and so on. So it's an easy method that students can grab into. 936 divided by 5, set up your legend. And I always start to encourage them, once they've done it a few times and they're getting pretty good at it. It doesn't mean they have to be super fast, but they're getting good at it and they're not making mistakes. I might say to them, okay, so do we want to go just a 5 every time? Or do you happen to know off the top of your head what 2 5s are? 2 5s are 10. Okay, well, why don't we just throw that in there? They might even say, oh, I even know what 3 5s are. Oh, was that? 3 5s are how much? 15. So it just bumps up what numbers they might use here. And that's already starting to get them to a little bit further on into the division that we want them to do. So additional examples are just that box method. This is a very popular method for students because I can break up any number and I can just put it into its own box. 20 times 4 is 80. 3 times 4 is 12. Add 80 and 12 together. Done. Lots of students, not just students who are struggling with math, love the box method. I could use expanded form like I showed you before. So that would be another possibility. So it's that little legend in the bottom corner here that becomes really significant. What number am I multiplying or dividing by? In this case, I can set up my legend and utilize that for whatever it's worth. Are there any questions about those or any comments? Okay, let's keep going. On your slide deck here, I put another hyperlink in here for you. I had mentioned to you earlier on and when we first started in August that we were doing curriculum support documents. So they have been renamed into CPAR is their acronym, Curriculum Planning and Assessment Resource. There is a number that are already done for grade 4. In this case, it's in the number section. So I've hyperlinked it directly to the ARPDC site. So I'm at the arpdc.ab.ca. And when you come to this site, if you're here now, but if you came to the general site, you would just come up to this green bar, select mathematics, and then there's a button that says CPAR. You click it on and it will take you to all the ones that were done for your grade. Now, the CPAR documents are done by organizing IDEA, and in grade 4 number, I believe there are 5 or 6 different numbered outcomes. So each numbered outcome gets its own document. If there's more than one row of cusps in the document, then the document will be quite long because each row of cusps is going to get a whole bunch of information. We were talking about 4N2, so let's go into 4N2 because we have posted that one already. 4N3 is coming fairly quickly as well. You just need to keep checking back to the site to see what's up and what's not there. So here's what the front page of it looks like. You will have a section in here which are all hyperlinks of everything from the progressions to New Learn Alberta to how do I read this document if you forget. There are some math planners and assessment planners. We're going to build specific ones for grades 4, 5, and 6. The verbs that you have in your skill and procedures are listed in here as well. You could click the 4 to 6 verbs on. That will give you a common definition that would make your definition the same as anybody else in the province. So we're not deviating and going kind of all over. I'm not saying you have to use those, but it just has a common language then. As students are mobile, they would hear the same things. It also gives you an exemplar of things that you might look at. And then you have your numbered outcomes document. So below that, here is your organizing idea, guiding question. This is 4 and 2. That was the learner outcome. Below that, you have a section describing transfer. And in that section, right now, you just have one sample summative. Remember, it's the learner outcome that we report on. So here's one sample summative that were done by your colleagues. There are more coming, and that will be part of the edits of these. Once a month, we'll go in, we're going to grab the documents, we're going to add in where people have written more material, put it in, and then repost them. So you just, again, need to come in and check to make sure that there has been no additions or deletions or whatever. When we go into the next part, you're going to get, these are the pre-assessments for the cusp that you're about to teach to the students. 4 and 2 only has one row of knowledge, understanding, skills, and procedures. If there was multiple, you're going to see multiple of everything I'm going to show you now. So pre-assessments, if you have the Nelson pre-assessment exams, here's the ones that you could use to test for student understanding. Here are the vocabularies. Here are the I know, I can statements. And then learning recovery is for students who are having some difficulties. What are some ideas that I can follow through on? And then you get into this side of the document, which is familiar to you. This is from your curriculum document. The only difference is all of your knowledge is there, your understanding is there, but only one skill at a time is showing. And that's because we know you have to teach the skill and assess the skill. So we've isolated the first skill, provided you with an achievement indicator from old curriculums that we've had in the past. So it matches to this. Here is the illustrative example. In other words, how do I teach this? What does this mean? Like, what am I supposed to do? Here's lots of examples, and you're welcome to cut and paste them and use them if you want to use them for teaching or a question or whatever. The sources are listed there, so you can always go and get more. And then the last column are formative assessments. So if you want to touch base and see how students are doing, they're formative. They're just, yep, they're getting it. No, they did not get this one at all. So let's go back and see what we're missing. So that's really what that last column is formative assessment. It is tagged with the words deep, surface. You'll see those words. And remember, at the beginning, we talked about what is surface, deep, and transfer. Surface teaching is I have new terms, I have a new formula, I have new something, and you're always going to have that. I have new things that I need to help the students unpack and understand before I can ask you to start connecting things and building deeper. So I have to do that initial stuff. There's no way you can get around it, but that's only about 10% of what we do. The 80% is the learning part, and that's the deep stuff where you take that foundational terminology and what you just taught me and start to connect it with different things. And that's really what you're checking when you go into a deep question. So this will go on like this. You'll see all these different illustrative examples. Here's your second skill that was listed in there. So new illustrative examples, new achievement indicators, and then another new set of assessments. And it just keeps going. I won't stop at this point. It just keeps going until I've reached all the skills and done all the skills. Below that, you'll have a section called resources. So for those of you that are using Mathology, and you all have access to that through New Learn Alberta, here are the correlations that fit to your specific cusp that you just taught. If you have Math Up in your school division, here's the linkages to what fits with Math Up. You all have existing textbooks in your schools. You don't have to have them all in front of the kids, but they do exist. I'd be shocked to find a school that doesn't have them. So Math Makes Sense 4 or Math Focus 4 will be in your buildings somewhere. And I've gone through and just linked what are the pages or units or chapters that fit to the current learner outcome that you're about to teach. So you could always go here for additional examples, there for additional questions if that's what you want. It's not necessary that every student get a book, but it does give you options then to go back. NCETM is a section that comes from, these are all links that come from the UK. And the United Kingdom did a lot of work for their teachers when they changed their math curriculum. They created resources that have virtually everything you can think of, you guys. It has the lessons, it has the PowerPoints, it has assessments, it has exemplars of how to teach it. There's pretty much nothing that you leave to wanting. We hyperlinked those that we thought were a match to your organizing idea or CUS that you are teaching. It might go beyond that, so you'll have to read it through and see. But these are available for you to go and have a look at and use if you need them. If you don't need them, don't worry about them. Don't go there. Additional websites that link to what you've just taught in that CUS can be found here. Indigenous connections are found right here. And then we also have resource support sites for planning. If you're looking for inclusion, if you're looking for differentiation, these are great links. And then the resources from other school boards that have shared with us whatever they have created already. If they were willing to share, those are listed here. And so those would not be specific to just number 4 or number 2. Those will be specific to everything that you teach. You just have to go through and find which one it is that you're talking about. And then gizmos. Karen Bloomhagen has gone in from Explore Learning, and she has already curated which ones match your learner outcome and your CUS that you just taught. And so if they're listed here, then you know that she's gone through them and vetted them for a match. The tasks that were created or curated by Calgary are in here, and you're welcome to use some of those as well. And then below that is a section called Literature Connections. It'll start to grow again. These are books that we found that you might want to have in your classroom or maybe in the library that fit to what you're teaching in that particular stream or CUS that you had. So those exist right now for 4N1 and 4N2. There'll be more coming very quickly. K-3 have all of the number. Everything that is in number is done in those grades, as well as patterns have already been posted. So you just need to go in and have a look through and find out what it is that you are doing. And I'm glad to say that by the time you get to doing the science, if you're not doing science already, the science are being posted right now. So the K-3s are being posted, and then after Christmas, Ted and I will work on the 4-6s. So for once, we finally get ahead of the game and have some things ready to go. All right, so let's have a look at this next one very quickly. I'm going to go really quick through this and just point out to you what's here. At the top, I said you might wish to consider doing 4N3 first, which is on the next slide. And the reason I say that is over here, you're going to talk about equivalent fractions, partitioning. You're going to get into those kinds of conversations. And if I'm going to have equivalent fractions, excuse me, knowing something about factors would be really helpful first. So when I do that, I'm just going to skip to this one first. So, okay, come on, 4N3, where are you? There you are. So 4N3 talks about factors of a number, talks about multiples of a number. It talks about whether the number's prime or composite. We did do that work already in the last slide deck, but you can use your quiz and error rods to help students find the factors of a number. You can find whether the number's prime or composite with that exact same step that they're doing. So kids see it. They see, what does a composite look like? What does a prime look like? What does a factor look like between two numbers? Well, in a quiz and error world, it'll be the same colored rod exists in both of them. So this is a piece that you might want to do before you start doing equivalent fractions. I can go into equivalent fractions and simply say, okay, so I can have this 1/2, and I could just multiply the top by 2 and the bottom by 2, the top by 3, the bottom by 3. Yeah, they can do that, but do they know what that really means? Do they really know what it is that they're finding? And so that's an important piece that we need to fill in. And that's why I say maybe do this work first, then come back to the fraction piece. This is a sample teacher's guide and student book, which are free to download, and you are copyright free. You don't have to worry about it. You can use some of it. You can use some of it, all of it, none of it. You have a look at it and see if there's something there that helps you. So the Cuisenaire rods would be my choice here to unpack this piece and work. And you can also look back at the old slides that we did. So let's go back to what you were doing over here, equivalent fractions. And we'll do more of that again at the end of February when we meet again. But in this case, you have another slide deck that sits in the background here. And I'll just whip through this very quickly. It will unpack pieces like, how do I get to unit fractions? What is a unit fraction? But one of the more important pieces is that we also have learned a lot about what are some of the pitfalls that we keep falling into when we teach fractions. For example, there's a study that's being done by Dr. Bruce, and she has been working on this since 2010 and still doing it. And it's an incredible research piece. But out of her work, she's found there's a couple of things that really stand out. And one of them is that North America, so we're talking about US and Canada solely, get outperformed in fractions in countries consistently. And there's some reasons for that. And if we could acknowledge that those reasons exist, then maybe we could sidestep some of those pieces. But this slide simply shows some of the things that she found are happening in fractions. For example, the students are going through it so quickly, they don't have time to really figure out that this is a relationship between numbers. They see the number as a whole number and a whole number. So then they get confused why you're saying 1/3 is not greater than 1/2. How can 3 not be bigger than 2? Because they're thinking in terms of whole numbers, not thinking in terms of a relationship. We move to the algorithm way too quickly. We go to, these are parts of a whole, and that top part is called the numerator, and the bottom part is called the denominator. And it tells me how many pieces there are. All true, but why do we have to get there in the first 5 minutes? We don't. We absolutely don't. We don't even have to name the fraction, nor do we have to use the word numerator and denominator. So inconsistent language is another one. So in some classrooms, the student said, the teacher always says 2/5. And then in another classroom, the teacher says 2/5. And then in another classroom, the teacher says 2/5. Well, the only one that's actually correct is 2/5, unless we're quantifying it in a problem solving out of something, like we explain what we're doing. That's a slightly different. But if this is the common language that's used in the school, so just as an FYI, when you have a PLC one day or a staff meeting, just put a fraction up on the whiteboard and see how everybody in the room answers the question. You'd be curious to see how your students experience that movement throughout the building. What kinds of words do they hear and language do they hear? They don't have a connection to fractions. So just because we said it's 1 out of 2 pieces, that doesn't mean anything to me. The other piece is that we don't spend enough time on unit fractions, which was the rock. Remember, that is the foundation, and you as grade 4 teachers build on the grade 3 foundation of unit fractions, really work lots with unit fractions, because when they get to grade 5 and 6 and they do multiplying, they need to pull out the unit fraction by themselves, out of the product, out of the factor, out of the fraction that's given to them. So it's really important that they have the right language and know how to find that. A lot of teachers said, I can show you how to do it, but I don't know if I even have the why behind some of those pieces. So that was something that she discovered in the research. Not everybody, but that's just the comments that some of them made. The overemphasis of part to whole, how North Americans go there so quickly. It's their first line. And then the other one is that the countries that outperform us do not use circles. They use them in the conversation after the students have learned something, but they don't start with cookies and pizzas. Look in our books. What do we have? Cookies and pizzas. Most of us would go to a cookie and a pizza if we talked about a half. I'm going to break the cookie in half. You get half, I get half. Well, you know what? A half isn't bad in a circle. But really the circle, if you think about it, is one of the most difficult shapes, because other than folding it in half and then folding it in half again to get a quarter, if I handed you all a circle right now and said, fold them into even fifths, we would struggle as adults. So the countries that outperform us don't use that shape. They use it, but not right up front. They use rectangles. They use hexagons. They use pentagons. They use things where the vertices can fold over each other and they can see them and they can find the folds. So something for us to think about as we have this new curriculum come through. Are there any things that we need to just maybe reevaluate the starting points? Not saying that we're going to change everything that we do, but is it different approach that we can do? This is a worksheet that I just took off the internet about unit fractions. And all they're trying to get to is how many parts does one of those represent? So all I have to do as a student is learn that, oh, what am I supposed to do? Oh, just count these. Oh, 4, okay, 2, 3, 8. You will never convince me that I know anything about unit fractions. You will convince me that I can count, but that doesn't mean I understand a unit fraction. So we are suggesting that maybe we hold off on some of the language that we use right off the bat and simply use the terms relationship, so that they're focused on there's a relationship, which means there's two numbers. It's not two whole numbers. There's this number that's on top and a number on the bottom, and they are somehow related. And they tell me something about it. And just starting with that kind of language first as related quantities. I'm not going to show this, but I would encourage you just to watch the first 2 minutes. This isn't, math antics are great. Don't get me wrong. I've used them, watched them, still use them. But in the first 2 minutes, watch what he unpacks and listen to the language. This is North America. This is exactly what we do. So it was interesting just to catch some of those things that she was talking about. So what you're going to see here is the development of the unit fraction using money to start with, because I know money. I figured it out. I know that I need 10 dimes to make 100 cents. So that would be like saying this is the first dime out of, and I'm going to use that word out of a total of 10 possible dimes to make a loonie. Okay, I'm going to explain and qualify it. So I could write it as this is my first dime on the number line out of the total possible 10 that are stretched all the way across. This is grayed out because I'm not actually using that language at all with the students. So I could put that on a number line. I could put cent signs behind it. Why do I want that? Because when I put the dimes on, I have 1 out of 10 possible dimes that I can see right here. I see this is my second out of 10 possible dimes, or I skip counted by 1/10, 1/10, 1/10, 1/10. But I could also say to students, this represents, the first dime represents what? 10 cents. 10 cents. Oh, how many cents are there in a dollar? 100. So this is 10 cents out of 100. So I could even write that as 10 over a possible 100 cents, 20 out of a possible. So we're starting to work our way into tenths and hundredths. The language will be there, but we're not just going to say, oh, decimal, first place is tenths, second place hundredths. Give me a context for it so that I can understand, right? And that's the important piece that I kind of want, if we can put the brakes on and just do a little bit of work with the unit fractions, that's important for them to learn. Okay, we're almost done, but if you need to leave, don't worry. I'm going to keep finishing the video here. So when we're doing these fractions, you could do nickels, but that's not imperative. It's not on your base 10. We also did quarters with the students. These are actually student sheets. And so when we put them all on one page, we actually had them just compare. We had them compare what happened at 50 cents. So at 50 cents, the student said, oh, like all of those relationships, the top number is exactly half of the bottom number. Like 5, 10, 2, 4, 10, 20. Okay, we didn't talk about equivalent fractions yet. We want them to talk about equivalent fractions. So when we go down to the end, we said, what happened when you got to 100 cents? Oh, the fractions, oh, the top numbers, they're all the same. They're the same as the bottom numbers. And then some of the students said, oh, okay, well, that makes sense then why in the last one, the top number was half, because it was only halfway there. So we said, well, that's interesting. So how would you how would you rationalize then that 50 cents could be written so many different ways? And students were pretty quick to say, it depends on the coin that you're using. But the pattern is kind of the same. And we did have some students who stepped up and said, but you know what? Like if you have that top one, you could just multiply the top by 10 and then multiply the bottom by 10. So they were starting to see the pattern of creating an equivalent fraction. Again, we can stand up and deliver it, or we can just be a little bit patient and do some of that work with them and just have them unpack it for us and see where they go. So this is a sheet that we used with the students. We said 0 is on the left, 1 is on the right. These are all equal jumps. So how would you mark these equal jumps? What unit fraction would you have and what would it look like? So in the end, it looks like this. So they were able to fill these in. I'll explain this. Some students liked the jump. So they used, this is my first 1 out of 4 jumps, my second 1 out of 4 jumps, my third 1 out of 4 jumps, which is really brilliant because this is grade 5, 6. When you multiply a whole number by a proper fraction or a unit fraction, I get 2 fourths. That's exactly where they're going to go. So it was good thinking on their part. They don't know that, but that's just what it is. This was just our question to the students. Do any one of these lines that you created these relationships for represent money? So they had to think a little bit about what bills, coins do they have that could represent money. And then what we did is we moved the 1. Now that's a little less grade 4, but we did do it with the grade 4s because if they're going to do their jumps, then they're going to jump more than 1. And that's okay, but we're not talking about improper fractions in grade 4, that's grade 5. But they did do it. They were able to go through and count how many jumps they were making. And in some cases we said, so what does this row represent? Quarters. How many quarters did you have here? 4 out of 4. How much is that? $1. Oh, okay. How many did you have here? 8. Oh, how much money is that? 2. So they actually could start to fill things in. Again, we wouldn't assess them on this, but just to show you the power of a unit fraction, I can count. I can skip count by that unit fraction and work my way down. So there are some activities here that you're welcome to use. And then here are some of the sources for the research that I've been following. All right, so to kind of finish this up, the last piece that you have is the angles. And remember the angle was, I can relate this now to a unit fraction. So now that I did all this work with unit fractions, now I could translate a unit fraction to a circle. So I could show them basically what 1 degree looks like. The top ones aren't so important, but I like the bottom one because if you watch right here as it changes, I'm able to show them just how big 1 degree is. And we say to them to go all the way around a circle, takes 360 of these. This is 1/360th. That's how big it is. That's what we call 1 degree. So I need 360 1/60th or 1/360th unit fractions to build a whole circle, which is what I showed them. I grabbed one that I had at home and just copied it, photocopied it so that they can see it because we don't typically use these, but it is nice for reflex. But here they can see that it starts at 0 and then it works its way all the way around to get 360, or they can go the other way, right? Start 0 on the other side and go around. So just so that they can see it. Whether you want to do the measuring of angles right off the bat, you can do that, or you can do that in February. There's no rush for this, but the link to the unit fraction is timely, and it's perfect for what you're doing right now. So we've already done this. We talked about the factors. This is a resource if you wish to use it. And then there are additional ones for fractions and decimals. So if you've gotten to the point where you say dollars and cents, and what did we notice about that where we had our decimal, what did we notice about what kinds of coins are on the other side? They're dimes. Oh, what kinds of numbers did we use for dimes? Tens. Okay, so we can start to build on that and start to work on the same thing for the dollars. So it just, instead of just imparting it, we get them to unpack it with us at the same time. Get the language to be the visible. Dimes are tens, tenths. right? I need 10 of those to get to a loonie. I'm not there yet. So whatever's on the right-hand side is still building to $1. And so I can help myself to understand the difference between a dime and something that's building. I put THS at the end to show that I'm building that portion of a one whole to get to the loonie. So there are a number of different resources down here, how to unpack tenths. This comes from the UK. This one comes from the UK as well, how to unpack hundredths. So if you're looking for some other ideas to go with that. And then here's an equivalence resource that you can use. So you've got lots of resources in here. I'm not sure that you're going to need all of them. It's a matter of kind of seeing what do you feel most comfortable with right now. The rest of these slides, I'm not going to go through them, are all about money that we have talked about once before. And I've just included them in case we have some new people that have joined us and they're not sure about how I might leverage money for place value. Then this is one way that I can do that. So this gives me those options and that opportunity. So at the end here, let me just grab our link. So I'll put this in the chat box, and this will give you access to the slide deck. And before anybody leaves, whoever's still here, can you just try it out? I want to make sure that you can get in so nobody's leaving without it. Not, I'll put the other link in. Okay, everybody able to open it? Okay, perfect. So we will post this. Like I said, I will find out what's happened to the second one. I don't understand why that's not there. And get those up along with the recording. And then this recording will be in that same location on the ARPDC site. So just look for session number 2 and session number 3 for grade 4. And that's where we'll find all of our resources. And then I think we see each other again sort of towards the mid or latter part of February. Here, stop the recording here just so that in case you have any questions, you're not on